Given the tables below, decide whether the function is linear, quadratic or cubic, and determine the equation of each function. So what we want to do here is use the method of differences. So this goes up by 3. This one goes up by 13. So 46 take away 17 is 29. 97 take away 46 is 51. 176 take away 97 is 79. And then finally 289 take away 176 is 113. So they're not the same. We need to take a second difference. So the difference here is 10 and then 16 and then 22 and then 28, and this one is 34. So we need to take another difference, and then they are all the same. So it's the third difference that's the same, and that implies that the function is cubic. So we know this is cubic, and therefore of the form y is ax cubed plus bx squared plus cx plus d. The a, b, c and d are coefficients, and therefore just numbers that we need to find. Now there's a shortcut for a. We can see that the constant difference is 6. When we have a cubic, whatever this difference is, we divide it by 6. And the reason it's a 6 is actually because 3 factorial, which is 3 times 2 times 1, is equal to 6. You don't need to know that at this stage, but I'm just telling you that's why it is. So 6 divided by 6 is 1, so we know that a is 1. So therefore we have x cubed, let's just put over here that a is 1. So x cubed plus bx squared plus cx plus d. We can find the d from our table, especially in this case because the x's go down to 1. D will be the y-intercept, remember, so that's when x is 0. So what we need to do is take the table back a step. So we know that the difference here would be 6. So if we count back on the second difference just here, it's going to be 6 less than 10, so that's going to be 4. So that would make the first difference -1. Now note, with the difference being 3 and going in this direction, we've added 3 on. But this time we're going this way, and that means whatever here had to have 1 subtracted from it to get to 1. So this needs to be 2. 2 take away 1 gives us 1. And that tells us d is 2. So y is going to be x cubed plus bx squared plus cx plus 2. Now for the b and c, we can use simultaneous equations. We could have done that for a and d as well. I just used a shortcut. So let's use these values here and these values here. So this tells me y is 1 when x is 1. Substitute that in and we get 1 equals 1 plus b plus c plus 2. So that gives me that b plus c is equal to -2. Let's call that equation 1. This tells me y is 4 when x is 2, so 4 is going to be. So if x is 2, then x cubed is 8. and then we have 4b, and then we have 2c, and then finally 2. So 4b plus 2c equals, so 8 and 2 are 10, 4 take away 10, that's negative 6. So 2b plus c is negative 3. Let's call that 2. If we do 2 take away 1, that gives me that b is equal to negative 3 take away negative 2, so that's negative 1. And then substitute back to here, and we can see negative 1 take away 1 would be negative 2, so c is negative 1 as well. And so we have y is equal to x cubed minus x squared minus x plus 2. Now what I have here on the calculator are the values from the table typed in to my statistics package. We can find the equation, once we've decided it's a cubic, we can find the equation in here. So we know it's a cubic, we go to regression and cubic regression. If we knew it was a quadratic, we'd go to quadratic. If we knew it was linear, we'd go to linear. But we know it's cubic. Our x's were in list 1, our y's were in list 2. Click OK. Tells us the equation is y is ax cubed plus bx squared plus cx plus d. And it tells us that a is 1, b is negative 1, c is negative 1, and d is 2. So let's look at b. We can see the difference here is 3, and then 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 3. So the first difference is the same, and that tells me it's linear. So we can say y equals mx plus c, or ax plus b, whatever you want to put down. So the point is here that the first difference was the same, and that implies it's a linear function. So, how do we find these? We could use simultaneous equations. Since the x's go up in 1, starting at 1, we could work out what happens when x is 0. So we'd need to go down another 3 here to negative 4. So that tells me that c is equal to negative 4. So y is going to be, now I could just go straight to the answer, because in this case the m is just this constant difference. If you think about it, we're going up by 1 here, going up by 3 here, so it's the gradient. So that's going to be 3x, take away 4. Then in part C, difference is negative 1, then positive 3, then positive 7, so 16 take away 5, that's 11, so this one's 15, and then this one's 19, so that's 4, 4, 4, 4, 4. The second difference is the same, so that implies quadratic. So we can say that y is ax squared plus bx plus c. Now there's a shortcut here for the a. The constant difference is 4. When it's a quadratic, we divide this by 2, and that's because 2 factorial is 2. So 4 divided by 2 is 2. So that gives me that a is equal to 2, and y therefore is going to be 2x squared plus bx plus c. Now we can use the difference trick to get at the c if we want to. I'm not going to do it that way though. I'm just going to use two values and do simultaneous equations. So I'll use these two. So when x is 1, y is negative 4. So negative 4 is equal to, x is 1, so this is going to be 2 plus b plus c. giving me b plus c equals negative 6. Let's call that equation 1. When x is 2, y is negative 5. Negative 5 equals, so if x is 2, that's 4 times 2 is 8, and then add 2b, add c, so 2b plus c is negative 13. So that, take away that, is b, and negative 13 take away negative 6 is negative 13 add 6, so that's negative 7. And then if we substitute in here, that must mean that c is equal to 1. Negative 7 add 1 will be negative 6. So we get that y is 2x squared minus 7x plus 1. Now, just to show, we can find that with quadratic regression on the calculator. So I've got the values typed in. If we go to calc regression, we know it's quadratic. And OK there, and we get a is 2, b is negative 7, c is 1.